Hi guys! I'm thinking about making a new video series discussing recent cephalopod news. I'm thinking about doing so because of a recent paper that was published talking about how some squid are able to survive in higher CO2 conditions. I'll be explaining this topic further later in the video. Please let me know what you guys think of this news in the comments. Breaking news! As I was making this video, a juvenile giant squid was filmed swimming on Wednesday, June 19th of 2019. This giant squid was found while a team of scientists were filming deep sea life 100 miles or around 160 kilometers south of New Orleans, Louisiana, in the United States. So this takes place in the Gulf of Mexico. The team was using a special lure that mimicked a deep sea jellyfish, its distress signal, and this distress signal would tell other things in the area that something is eating it, and they need to come and eat the thing that's eating it. The signal has been used before to attract giant squid, and it worked again, and the giant squid it tracked before was way back in 2012, south of Japan. I think south of Japan. So here's the video of the giant squid that they found. As I mentioned before, this is a juvenile giant squid, and it is estimated to be only around 10 to 12 feet long, or around 3 to 3.7 meters long. The giant squid are able to get up to 44 feet, or 13 meters long, but there are several reports that giant squid can get longer than this. I personally have been waiting for a good giant squid sighting in many months now, as the most recent one was in August of 2018 when a giant squid washed ashore on a New Zealand beach. And so this is super exciting for me. We know what method works for finding giant squid now, and hopefully we can use it again in the future to further learn about these amazing creatures. Now back to the rest of the video from before the recording of the giant squid poked its tentacles into a camera. To start off this series, an article was published to Conversation Physiology on June 7th of 2019 showing an experiment that a group of marine biologists did on two different types of squid. The bigfin reef squid was one of the squids, and the other was the two-toned pygmy squid. I originally said something like, the pygmy squid is more related to the cuttlefish in this segment than the longidae squid, the bigfin reef squid, but the problem is we don't really know. I'm looking at this one evolutionary chart, and it's really confusing even that. And so, I think it's up to debate which one's more related to the cuttlefish or not. Now, back to the video. The experiment was trying to see if these two squid species could survive in end-of-century CO2 conditions. These CO2 levels are predicted to be 900 parts per million, or ppm, by the end of the 21st century, unless we take drastic measures to try and curb climate change. The researchers predict that the squids wouldn't fare well under these conditions because of their high-energy lifestyles and because of the way their blood cells bind to oxygen. They looked at other experiments from previous researchers and found that the way a squid reacts to CO2 conditions depends on the species of squid and its current life cycle stage. To see how well the squids were able to take in oxygen in the CO2 conditions, they basically pushed the squid to their limits in exercise and then placed them in respiratory tanks. They had a tank with a controlled CO2 level and a tank with an end-of-century CO2 level for each squid tested. To be precise on the ways that the squid got exercise, they chased the pygmy squid with a net in a bowl for 3 minutes, and for the reef squid, because of their size and because they accidentally jet into the walls of the tank, they lifted the squid out of the water for 5 seconds, and then put it back in the water for 10 seconds, and this was repeated for 3 minutes. They recorded how many jets and inks of each squid of both species did during the tests. The pygmy squid were brought out of the water for 15 seconds and then put in the respiratory tank after the exercise, while the big fins were taken out for 30 seconds before being put into the respiratory tanks. The big fins tried jetting out of the net that they were in whenever they were put into the water during the test, but both the big fin and the big pea squid stopped jetting before the whole 3 minutes of testing were up. Then they measured how long it took the squids to recover while in the respiratory tanks. The major variables that they tested for during the entire experiment were the routine oxygen uptake in the squids and the maximal oxygen uptake in both squids. The results of the test were interesting, as the high CO2 levels barely affected the pygmy squid. The recovery times in both conditions showed to be on average just under an hour. The difference in O2 routine and maximal uptake in a pygmy squid were barely affected as well. The big fin reef squid had similar results with how their O2 uptakes amounts were barely changed, and the recovery times for big fins barely changed to each other as well, with the controlled averaging around 8 hours and 8 minutes, while the manipulated averaged 7 hours and 43 minutes. The scientists in the study conclude that these squid aren't affected by end-of-century CO2 levels like how some other species are, and could probably survive in those conditions. They note that while these species are able to survive in it, others might not be able to. Here is a quote from the last sentence of their conclusion. However, as some previous studies have observed negative effects of elevated CO2 levels on respiratory performance of some cephalopod species, it will be important to understand the potentially species-specific and life-stage-specific effects which can have critical implications for the structure of marine ecosystems in the future. One of the reasons why the recovery times for the pygmy squids were so much shorter than the big fin squids is because they have a special gland on the top of their mantles that allow them to stick to surfaces, usually the underside of seagrass. In this experiment, they clung to the wall and chilled there. The big fins, on the other hand, have to keep moving in their resting state, as they basically hover in one spot by moving their fins. I personally think that after hearing about all this and reading the article, that squid have a pretty high chance at surviving ocean acidification and climate change, just because of how fast they reproduce and the massive variety of them. We could potentially see several new squid species emerge over the next 50 to 70 years because some squids are better adapted to these new conditions than the current squids. How do you guys feel about this news? I am excited to see what is in store for these squids. It's been a while, as I always say in my videos. I feel that if I make a video on all the new exciting squid and other cephalopod news, that I could actually have a decent uploading schedule. But over the past months, it's really just been whenever I feel like it. I am excited to continue the Squid Anatomy series, and want to start another one called Squid Profiles, where I make a video explaining and talking about all we know about a specific species of squid. There would be a different squid for each video. Do you guys like that idea? I also have a few other video ideas floating around, such as a comparison video between the giant squid and colossal squid, or between a squid and an octopus. YouTube isn't really my main focus, but I hopefully can actually make a lot more YouTube videos just for the sheer fun of doing so. I hope you guys liked the video, and remember to keep exploring. Oh, and before I go, I have a Twitter that I use for this channel called @SquidsDiscoveries. Go follow that if you want.